Hi, welcome to my video on the derivative of a variable, and this is the first video in the new unit that I'm going to do on maximum and minimum word problems, but these maximum and minimum word problems are on level 2. I did a maximum and minimum word problems level 1 in the previous video, but now this is one I call level 2, more difficult. But before we start that, let's go over the idea of doing a derivative of a function. Notice that I have d dt. These are all t's. So this is the same as if you had d dx and you had all x's. So this would be 2t plus 6. Derivative of negative 2 is 0. Now I have d dr because I have all r's. So the derivative, again, the same as if it was an x, is 2r minus 4. I have d dr again. Notice the derivative is, the variable is r, and normally we're related to the radius because pi r cubed is the volume of a cube. But the derivative in terms of r, pi is a constant, so it's pi, 2 pi r, or sorry, 3 pi r squared. I got lost then. So 3 times 1 is 3 pi, the exponent decreases by 1. Now I have d dh because I have all h's. So the derivative of this function in terms of h is 2 times 3 is 6 h squared. You multiply the coefficient by the power, you get a 6 and decrease by 1. And 6 times 2 is 12 and decrease the power by 1. So you get 6h squared plus 12h. Again, the derivative is the same as if you're doing it for x. Now we have another one, because you're going to see some of this when we go further in the calculus. d dw. Notice I have all w's. So that means negative derivative, negative 3 times 2 is negative 6w, decreased by 1. And 6w, 1, that's a 1, understood. So 1 times 6 is 6, and it decreases by 1. So w to the 0 is 1. Derivative of a constant is 0. Again, I'm reviewing because coming up you will do d dt, you will do d dr, etc., etc. Number 6, what about d dr? Again, I have an r, so this is 4 over 3 times 3, that's a 4 pi, and the exponent decreases by 1. And this is a constant, so 4 over 3 times the constant stays. And we'll do a little proof on that, or the property of constant multiple, later on. Now I have another sort of showing you about the derivatives. Notice number 7, I have 2l plus 6w equals 18. And I have a equals lw. Now, question A, express w as express L as a function of w. That means I have to solve this equation for L. So 2L equals negative 6W plus 18. Divide by 2, L equals negative 3W plus 2 and 18 goes 9. So now I have L as a function of W, so that means L is on the left and W is on the right. Now I want to find dl dw. Now dl dw is, this is L and W, so dl dw, I have to do d dw of the L, and I have to do d dw on negative 3w plus 9. So dl d dw on the L is dl dw, and d dw on negative 3w plus 9, derivative of negative 3w is negative 3, derivative of 9 is 0. So again, in order to do dl dw, I have to have L expressed in terms of w, that's why I solved this equation for L. And So the length is a function of the width. What about if we want to express the W as a function of the width? So we want to express W as a function of the width, and then we want to find W in terms of L. So that means W is on the left, L is on the right. So I take this equation, and I got 6W is equal to negative 2L plus 18. And I want W as a function of L, so W is on the left, L is on the right. So divide by 6, and I get, divide by 6, okay. So I get W is equal to 1/3 L plus 3. Now, to do dW dL, W is on the, again, the top is on the left, and the denominator is on the right. So I have to do d dl of the W. I have to do the derivative of d dl of both sides. So this becomes d dw dl right here, and d dl of negative 1/3 L plus 3. The derivative of a negative 1/3 L is negative 1/3. Derivative of 3 is 0. Again, this is a 1, so 1 times negative 3 is negative. 1 times negative 1/3 is a negative 1/3. Decrease this by 1, and we get L to the 0, which is 1. And derivative constant is 0. Now, another part. Express A as a function of W. Find dA dW. So if A is a function of W, up here I got A as a function of L and W. So I have to, if I want A as a function of W, I want to do the derivative of A in terms of W, I got to have the area on the left and the width on the right with no length. So if the area is LW, that means the area is a function of L and W. But I want the area, so I want the area as a function of W. So that means I have to replace the L. So L is a negative 3W plus 9. So that means the area is negative 3W squared plus 9W. Notice the area is a function of W. So now I can do dA dW. So d dW on the A, and d dW on the negative 3W squared plus 9W. So d dW of the A is dA dW, and the derivative of this binomial in terms of W, they're all W, so it's negative 3 times 2 is negative 6W. Derivative of 9W is 9. So dA, that's the derivative of the area. If you think of this as a rectangle with length and width, and the area of the rectangle is length times width. So now we have the area, the derivative of the area as a function of W is this answer here. Express A as a function of L. That means, and to do that, if we do that, then we can do, if we have A, area as a function of L, then I can do the derivative of the area in terms of L. But that means that if I do the area in terms of L, I have to get rid of the W. So according to this equation here, W is equal to 1/3 of L plus 3. So W is equal to 1/3 of L plus 3. That means the area is 1/3 L squared plus 3L. Now I have the area as a function of L. Now I can do the derivative of the area in terms of L. So d dL on the A, and d dL on the right side, and that gives me dA dL The derivative of this expression, which is all L's in terms of L, is negative 6L plus 3. Okay. Everything should be perfect. 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 Okay. Just thought I made an error there for a second, but everything looks like okay. Because we can make an error. It's easy to. Number 8. I have a rectangular box, and the height of the box is h, and the base is e and e. Said h is equal to 4e. That's the height. It's in terms of e. V is the volume, and e is the edge length. So this is the length. So that means at the bottom of this box is a square, and so the bottom of the box is a square with a height of h, and we have a volume of this box. So the volume of this box is the volume of a rectangular box is L times W times H. So the volume is E times E, the length and the width is the same, times the height. So the volume is E squared times H. But notice here, it says I want the volume in terms of E. Right now, if I did the derivative, I would have to do the volume in terms of E and H, but I only want the volume in terms of E. So that means I have to replace the H. So the H is equal to 4E. So that means the volume is 4E cubed. Now, when I do dV, or derivative of the volume, in terms of E, I have volume and I have E, perfect. So I do d dE with the volume, and d dE on the monomial on the right side. So that gives me dV dE, and the d dE of 4E cubed is 4 times 3 is 12. The exponent is decreased by 1 to a 2. So notice, again, the volume has E and H's, but I only want the E. So because the height is in terms of E, then I can have all E's that'll enable me to do my derivative. This is the same as if you had d dx. So the E, or dx, d dx, d dE is the same type of derivative of a polynomial. Number 9, last one here. Show that dV dr of the volume of a sphere is the surface area of a sphere. So dV dr of the volume. So the volume of a sphere is 4 over 3 pi r cubed. So if we do the derivative of this volume, so that means we do d dr times v d dr times 4 over 3 pi r cubed. So this gives us dV dr, that's the volume, and that's the derivative of the volume in terms of the radius. So we have d dr, so this is one variable, that's a constant. So 4 over 3 times 3 is 4 pi, and decrease the exponent by 1, we get r squared. But if you learned anything, we know that the surface, I'm going to call it SA, the surface area of a sphere is 4 pi r squared, if you learned it. That means that the derivative of the volume, dV dr, is the surface area. And I'll just spell that out just to make sure. Surface area. So the derivative of the volume in terms of r is the surface area. And that's how I remember. A volume is cubic, surface area is square. So to do the derivative of this term here, you will get 4 pi r squared. And that's how I remember. I know what the volume is, 4 4 over 3 pi r cubed. When I do the derivative of that, I get the surface area, because you're going from a volume down to a quadratic. If you do the derivative of this quadratic, you go down to a linear, which we practiced earlier on. So that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.